This video is on the different trig functions. The three trig functions are sine, cosine, and tangent. The sine of an angle represents the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. To remember these functions, you can use the term SOHCAHTOA. The S in SOA stands for sine. O stands for opposite, and H stands for hypotenuse. The C stands for cosine, A stands for adjacent, and H stands for hypotenuse. TOA, the T stands for tangent, O for opposite, and A for adjacent. So the way that you look at this triangle and figure out some trig ratios is like this. If you're asked to write a trig ratio for the sine of angle 2, so I'll go over to this picture and you always look at the angle that it's talking about. That's where you start. So here's angle 2. Here's angle 2. And if I'm looking for the sine of it, sine means opposite over hypotenuse. So I start with angle 2, and opposite means across. So opposite of angle 2 or across from angle 2 would be 7. So we put 7 here. So that goes on top, and then hypotenuse is on the bottom. And hypotenuse is always across from the 90. So we could draw our angle here. Hypotenuse is always across from 90. So when we look at that triangle, the side across from 90 is 15. So the sine of angle 2, the ratio would be 7 over 15. When we look at the second example, so for this example 2, we want cosine of angle 2. So again, we're starting with our angle. So when you start with angle 2, and cosine is adjacent over hypotenuse, adjacent means right next to it. When we look at our angle 2, we actually have two sides that are right next to it. You have this side as well as this side. This side right here is actually the hypotenuse. Since it's already the hypotenuse, we are not going to use it as our adjacent side. So for cosine, our adjacent side has to be the 4 square root of 11. It's right next to it and it touches it. So we would write on the top 4 square root of 11 over our hypotenuse right here is still going to be 15. So we would write 4 square root of 11 over 15. And this is what we would give for our ratio. For this third example, we have tangent of angle 2. So we know tangent is opposite over adjacent. So we need our opposite of this angle 2. So the side across from it, and we know that that is 7. So I'm going to put here equals 7. Adjacent, or next to it, we know that that would be 4 square root of 11, and that's on the bottom. So I would write 4 square root of 11. So there's a radical in the denominator, so we need to rationalize. So we would multiply the top and the bottom by square root of 11. Which will make, I'm going to write it down here so I have space, would make it 7 square root of 11 divided by 4. Right here we have 4 times 1 would be 4. And then square root of 11 times square root of 11 is just 11. So I'm going to write this as 4 times 11. So we'll end up having 7 square root of 11 divided by 44. And that's what our ratio would be that we would give for our answer. We put 3 more practice problems here. So I'm going to give you time right now on your own to solve for these from the previous figure from the page before. So I'm just going to pause the video and give you time to try to solve for each of these trig functions. For sine of angle 1, you should have gotten 4 square root of 11 over 15. For cosine of angle 1, you should have gotten the ratio of 7 over 15. And for tangent of angle 1, you should have gotten 4 square root of 11 over 7. Inverse trig functions would be inverse sine, inverse cosine, and inverse tangent. These trig functions are used to find the measure of angles. So, for example, number 1 right here, you see this triangle. We have this side that's 11, this side that's 7. We don't know this side yet, but we are trying to figure out what this angle measurement is right here, this angle X. So the way that you solve for these is you identify which side you are given according to X. So when I look at this triangle right here, here's my X. Which sides am I given? Well, this one right here, the 7, would be considered the opposite of X. And this right here, the 11, is across from the 90. So that would be considered my hypotenuse. So if you think about which trig functions deal with the opposite and hypotenuse, that would be SOA. So deals with the opposite and the hypotenuse. The S is the sine function. So when we set it up, we would do sine of X. So I'm just going to write sine X. And this X right here is always the angle. And when we write the ratio, well, sine is opposite over hypotenuse. So that would be 7, my opposite over hypotenuse, over the hypotenuse. So in order for us to be able to solve for X in your calculator, you would type in inverse sine 7 over 11. Okay, so you would type in inverse sine 7 over 11. So this is sine inverse 7 over 11, which is what you would type into your calculator. And when you type that in, you would get that this would be approximately 39.5 degrees. So that means that this angle X up here is approximately 39.5 degrees. If I look at this triangle right here, again, identify your sides according to X. So here's X. So your angle is always where you start. So I'm going to start here. The sides that I'm given, I've got 3 over here, which would be adjacent to my X. So that's A. And this side right here is hypotenuse. So I've got adjacent and hypotenuse. And this one we had so, and then I know that the one that deals with adjacent and hypotenuse would be ca, and the C stands for cosine. So cosine deals with adjacent and hypotenuse. So when I set this up, I'm going to do cosine X, which is my angle again, equals, and we know that cosine equals adjacent over hypotenuse. So my adjacent side was 3 over my hypotenuse is 3 square root of 5. And then since I'm searching for an angle in your calculator, you're going to want to type in inverse cosine. So we'd have cosine inverse, and then we want to say 3 divided by 3 square root of 5. And since we've got more than one thing down here, we want to protect this denominator. So we put them in parentheses. And when you plug that into your calculator, you should get approximately, and I'm going to write that down here, 63.4 degrees. So that means that this angle X here is approximately 63.4 degrees. That's what you should come up with for your answer. Test it out, plug those into your calculator, and make sure you get the same answer, same result.